Okay, welcome to the Henstitute. Today we're going to do a little review of some of our main electrical concepts: electric potential, otherwise known as voltage, electric current, electric resistance, and electric power. So we'll start with the concept of electric potential. Now, electric potential gets its name because we are actually talking about energy. So if you remember, this is actually the energy per unit charge. We usually call this voltage, so that's why it's going to be labeled with a capital V, and it's measured in volts, named after good old Alessandro Volta, the inventor of the battery. And so it would be energy divided by charge. And so in our particular case, that would be our battery. That's our voltage source. And if you remember, it has a positive and a negative side to it. And we might say this has 12 volts, which basically means it's going to give 12 joules of energy to every coulomb of charge that actually travels out there. So a joule per coulomb is actually the same thing as a volt. The next one that we have is the idea of electric current. So once I hook this up, we're going to get some electric current to start flowing through this circuit because we've connected it across something that it's going to use up this energy. So we get electric current. Now, current is actually the amount of charge flowing over time. Now, we typically refer to the intensity of the current, so that's why we use an I, and it's Q, the charge, divided by time. So an amp, which is what we measure current in, is actually a coulomb per second. Now, in this particular case, I have drawn it as in the direction that electrons would move. So electrons would be going from the negative side and moving through the circuit and going to the positive side. If you actually follow the original concept of Ben Franklin, he said that we actually had positive flowing this way through a circuit and going back, and they refer to the direction of that. So this is what we sometimes call conventional current. However, for what we need, conventional or electrons, it does not matter. So if I said that there was so much current going through here, for example, if I had 4 amps of current, it means if I were to look in this wire, I have 4 coulombs of charge passing through every second. And if you remember, if you even get fancy, a coulomb, it takes basically 6.25 times 10 to the 18 electrons to make 1 coulomb. So you're talking about billions and billions of electrons moving through this circuit. The next one that we have up here is the device we've connected, this device up here. And we talk about electrical resistance. So we've got our electrical resistance up here, electric resistance. And this electric resistance is basically the amount of current that's being slowed down or something that's going to use the energy that's coming out. If we follow good old Georg Ohm, he said that the resistance of an object was the ratio of the voltage across that object to the current going through it. So we measure resistance in ohms, and we refer to that as a volt per amp. And in this particular case, let's say if I had 12 volts across this resistor and 4 amps going through the resistor, then when I take 12 divided by 4, my resistance here, 12 volts over 4 amps, would actually be 3 ohms of resistance when we have this going out. And if you remember, the way I kind of thought of it is I always think of these electrons or this charge moving around, and they have the voltage. They're going to spend some of that voltage and go around. So the last concept we'll kind of deal with is electric power. And electric power is really like the total amount of energy. So It's actually the product of your voltage and your current, and it's measured in watts, which stands for a joule per second, but it can also be a volt times an amp. So both of those units will work. And in this case, if I had 12 volts and 4 amps, if I take 12 times 4, I get 48 watts of power. And so what that means is that is the total amount of energy being used per second. So as these electrons are zipping through this circuit, they are using up 48 watts. This is kind of the 4 major concepts when you deal with electricity and everything that we have already had. So this is just a little bit of a review. Enjoy. Hope you are getting as much as you can from the Henstitute as we just are beginning.